Now that you understand what a hypothesis test is, we're going to do a specific type of hypothesis testing. We're going to start with testing for the mean, where we have large samples, where the population standard deviation is known. That's the population standard deviation. So we're going to use the rules that we discussed in 7.1 to find a p-value and then compare that p-value to alpha, the significance level, and decide whether we reject the null hypothesis or fail to reject the null hypothesis. Okay, so this is just a reminder of all the steps that we learned in 7.1. If we have a p-value for our hypothesis test that's equal to 0.0237, we have to decide what our decision is for the level of significance. So we're going to start with a level of significance of alpha equal to 0.05. Our p is equal to 0.0237, and we're comparing that to 0.05, which is equal to our alpha, and 0.0237 is less than our alpha. And when it is less than alpha, then we reject the null hypothesis. In this next one, we have an alpha of 0.01. So again, we have 0.0237, and we're comparing it to 0.01, and it is greater than, that's our alpha, that's our p. So this means we fail to reject the null hypothesis. Sometimes we have to find a p-value. We're going to do a left-tailed hypothesis test with a z-score of -2.23, and we need to decide whether or not we reject the null hypothesis when the significance level is alpha of 0.01. Okay, so if we have a left-tailed test, that means our picture looks like this, and this is our z-score is -2.23. That means when we do normal CDF from -200 way over here on the left side to -2.23, this point on the right side of the shaded region, that's going to spit out our p-value. Our percentage of the shaded region is what it is, and that gives us a p-value of 0.012873673. Now we're going to compare 0.0129 to 0.01, and it's greater than. That means we fail to reject the null hypothesis. In the next one, we have a two-tailed hypothesis test. That means that we have both ends that we have shaded regions on. We know that z is equal to 2.14. That means this is negative z of -2.14. In order to find this one, we have to do this is half of alpha, and this is half of alpha. Well, actually, that's half of p. And if we do normal CDF of negative 200 to negative 2.14 and add that to normal CDF of 2.14 to positive 200, that will give us our p-value. Now those values are going to be identical, so we could just multiply it by 2. So when we do normal CDF of negative 200 to negative 2.14, we get 0.0161773252, and then that would be plus the same exact thing, which gives us a p-value of 0.03235460505. We're going to compare that 0.0324 to 0.05. It is less than. That means we reject the null hypothesis in this case.